I1, I2 here, and I3 here. So just apply I don't know. Haziq. No files for lecture. Haziq. Before this, can you see the material? Sebelum ni ada Haziq. Then I think something happened regarding the internet connection. Maybe you can log out and log in, or you change your browser. Okay. Or tutorial ada. Okay. But your friend can download it, can find the slide and can download it. So I think okay, Anwar. Okay, so this is let me proceed. Okay, so I think Haziq can try later, find it, and if you still cannot find it, you may ask from your friend. Okay, some of your friends have download it. Okay. Boleh buka je slide yang baru tapi kat laptop. Make sure itu general. Baru tapi kat laptop. Habis tu, Aulia. So what's the problem, Aulia? Kat laptop. So what's the problem, Aulia? Okay. Okay, so this is very basic. At A, so what principle here we apply? What principle? Ohm's law, KCL, KVL?
KCL.
Good. Buka kat phone. Okay. KCL, right? So, okay, apa ni KL? Kita tinggal see. So, at A, current enter equal to current. Leaving the note, so current enter is I1 is equal to 6 plus 1, right? I1 is equal to 6 plus 1, and we will get I1 is equal to 7. And then at B, C is equal to I2 plus 7. C is equal to I2 plus 7, and we get I2. At C, 7. Please mute. At C, 7 is equal to 2 plus I3. Okay, 7 is equal to 2 plus I3, and we get I3. This is very basic. Any question? Any question? Please type no here so that I can proceed to other slide.
No.
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 Okay.
No.
Okay, so this is good. So that I'm not talking alone. So the other example, this is also very basic. Obtain I1 and I2. I just put the note here and name it as 1, note 2, and note 3. So at note 1, current enter is I1. It is equal to minus A plus minus C, right? I1 is equal to minus A minus C. Okay, I1 is equal to minus A minus C, and we get I1. Okay, and then at note, what else? At note 2, current enter is 4 and minus A. 4 minus A, it is equal to I1 plus I2. Okay, and then we substitute I1 into this equation, and we get I2. Okay, that's all. Can I understand? Type yes here. Very basic. Yes. Okay.
Yes.
Okay. This is the next example. Find current and voltages in A. This is the original circuit, and then this is after after I put loop 1 and loop 2, okay? So, how to solve this? Give the name of the equation here. This is the principle of Ohm's law, KCL, KVL.
Ohm's
law.
Ohm's law. Okay, how about others? This I1 equal to I2 plus I3. Ohm's law, Rizky. Okay, how about others?
KCL.
Sorry, KCL, Doctor.
KCL.
KCL. This is KCL. Okay, when you see the current in the equation, all the terms are in current. Okay, current. So it is KCL. So
entering the node, right?
Yes, current enter a node is equal to current leaving the node. So I1 is equal to I2 plus I3 KC. Okay, so this is our first equation. I1 is equal to I2 plus I3. And then we should find more equation because we want to find all currents, meaning that I1, I2, I3, and then all voltages, which is V1, V2, and V3. So what else? We apply KVL in the first loop. So let's say I use the first sign, minus 30 plus V1 plus V2, okay, is equal to 0. Okay, or we substitute, and then we substitute because our equation here is in terms of current, right? This is in terms of voltage. So how to solve current and voltage? So now we substitute V with in terms of current, okay? So V1 here, it is equal to I1 multiply with 8, right? So 8 I1. Are you okay?
Yeah, we're okay.
Okay, and then V2, how about V2? 3 multiply with I2 equal to 0, and then we take we find I1 from this equation. So I1 is equal to 30 minus 3 I2 divided with 8. Make it as the second equation, and then we find KVL in the second loop. Okay, now we still we have I1. Okay, this is equation of I1 and I2. Okay. We have 3 unknown here, I1, I2, and I3 in the first equation. So meaning that we should have 3 equation. This is the first equation. You can leave as this equation or make it I1. And then let's find other equation. Apply KVL in loop 2. So positive V3 minus V2, okay? Positive V3 minus V2 equals 0, or you may write as minus V3 plus V2 is equal to 0. Okay? So V3 is equal to V2. Okay? So now let's substitute V3 and V2 because our equation is in term of current I and I. Okay? So V3 is equal to I3 minus multiply with 6, right? I3 multiply with 6. Our V2 is 3 I2. Okay. Now let's take out I3. It is equal to I2 divided with 2. Now we have 3 equations. Okay, then we can solve the equation. There are 2 ways. Okay. This is the first method. It is substitution. Okay, substitution. So we substitute the second and the third in the first. I1 is equal to 30 this, okay, this one. And then what else? Minus I2. Minus I2. I2 is, okay, make it I2. And then minus I3. I3 is this one, equal to 0. And then we will get, from this equation we get I2, I think. I2. So what is I2?
Doktor, question doktor.
Huh?
Ada question nak tanya sikit.
Yes.
For the loop 1 tu, can kita apply KVL. So from your punya jalan kerja ni negatif, you guna sign kan? Negatif 30 plus 8 I1 plus 3 I2 right?
Yes.
Tapi kalau kita guna persamaan voltage supply equals to voltage drop, boleh tak? Mean kita tak guna sign tu. Kita tak nak pandang sign. Tak nak tiru. Tak boleh. So dia akan
Can and then you will get 30 is equal to V1 plus V2, right?
Yes, correct.
Same like this. 30 is equal to V1 plus V2, right?
Yes.
Okay. Actually, what is I2? Missing here. I2 is equal to? Okay, calculate it now. I2 is equal to? Yes, I think so. Get the same answer as Chan Yang Kang. How about other student? Got the same answer? Okay, and then I1 is equal to this and this. Okay, class, do you know how to solve equation using calculator? Type here, yes or no? Do you know how to? No. Yes, okay. Then if you know how to solve equations using calculator only, okay, you just give 3 equations in your calculator and finally you will get the answer I1, I2 and I3 without using substitution method. Okay, the first equation is this, so you have to rearrange. Your first equation will be okay, this is your first equation. It will be I1 plus 3 I2 equal to 30. Okay, this is your first equation, and then this is your second equation. Okay, so this is your second equation, minus 3 I2 plus 6 I3 equal to 0. Okay, the other equation, okay, this is the other. So you have 3 equations. This is the first equation, the second equation, this is the third equation. Okay, so you have 3 equations and you can use calculator to solve it. How to solve 3 equations or 2 equations or 4 equations in calculator? I will teach you later, but you can search it yourself. Okay. In calculator, you just put the constant of each term. Okay. No need to do substitution, and you will get I1, I2, and I3. But the provided that you should rearrange your equation in terms of I1, I2, and I3. I1, I2, and I3. Same like this, I1 will be, so minus I1 plus I2 plus I3 is equal to 0. Okay, I will teach you later, but you can search yourself. Anything you want to ask about this question? If not, type no here.
No, still working on it.
Okay, good. Good. So that I know that you are with me. This is KCL and KVL and Ohm's law principles. Okay. So we go to the next. This is the very basic principle of KVL. Okay. Very basic KVL example. Okay, obtain V1, V2 and V3. Okay, so I name each loop as this, loop 1, loop 2 and loop 3, up to you. So for loop 1, minus 40, minus 50, and then we have positive 20 and plus V1 is equal to 0, and we will get V1 is equal to this. In loop 2, okay, minus 20 plus 30 minus V2 is equal to 0. We get V2. In loop 3, we have V1 here. So minus V1 plus V2 plus V3 equal to 0. And we will get V3 is equal to V1 plus V1 minus V2, right? V1 minus V2, we get 60. Can I understand this? If can understand, type yes here.
Yes.
Okay. Okay, good. Okay, this is the next example, the very basic example also. Okay, so this is very basic principle of what? KVL, KCL, Ohm's law?
KVL, madam.
KVL, okay. KVL, find current, I. Power dissipated by each resistor, by the resistor, and the power supplied by each source. So you have to find I, the current flows in this circuit, and then power for each element. Okay, so we apply KVL around the loop. We get minus of minus 8, and then minus 12 plus 10 plus 3I. 3I is the voltage of 3 ohm. And we get I is equal to minus 2. Okay, so the current flows here is minus 2. Okay, it flows in counterclockwise. Okay, like this notation. Or you may, we can also say that current of 2 amp, okay, positive 2 amp flows in counterclockwise. Same. Okay. So power dissipated by the resistor P of this is I square R, because we only can use this formula if we use V square over R. So we have to know the voltage of 3 ohm. If you use P is equal to IV, we have to know the voltage drop across 3 ohm. So now we just use I square R because we know the current flows to 3 ohm. Okay, so I is minus 2 squared multiplied with 3, we get 12 watts. Okay, and then power of 12 is, let's use P is equal to what formula? P equal to?
VI.
Yes, VI. So V is 12, current is minus 2, we get minus 24. Okay, this is the normal or the typical arrangement of voltage source, where current enter the negative terminal or flows from the positive terminal. Okay, this is not the normal arrangement of voltage source. 10 volt. Okay, so P of 10 volt is, I put minus here. Okay, why minus? Because the voltage source is arranged in opposite direction. I mean opposite arrangement, right? Opposite of the normal. This is the typical, this is not the typical. Okay, positive then negative. Get what I mean? So I put negative here, negative 10, and then the current is the same, -2, and we get 20 watt. And then this is the normal arrangement of voltage source where the current enter the negative terminal of the voltage source. So just take the value of the voltage source, -8 multiply with the current is -2, we get 16. Can understand?
Yes,
Any
Doctor.
question? Any question? No? Please say no. No. Okay. No. Now we go to the last, I think the last example of basic KVL. Okay? Basic KVL for determining I naught. So we can apply KVL in the loop. So let's start with 54 voltage source. -54 plus 22 I naught plus, okay, plus this 5 I naught equal to 0, and we will get I naught is equal to 4 amps. That's all. Can understand? Say yes.
Yes.
Okay. This is very basic, okay? But the advanced question is discussed earlier with previous class, and I have uploaded the video here. Okay, it is tutorial 2. I think this one, tutorial 2. Yes, this is the latest video that I uploaded, tutorial 2. Actually, I discussed some question in tutorial 2 regarding Ohm's law, KCL, and KVL. Okay, and the solution, this is the video, okay, and the solution. So what in the video, it is the question in this slide as well, okay. So so previous class I discussed this question, okay. So it seems like advanced question, this one, and then this is very basic, very basic. This is also very basic, okay. Yeah, I think that's all. Okay, so now any question regarding Ohm's law, KCL, and KVL? Next week, okay, we will learn about series parallel, voltage divider, current divider, and star delta transformation. Okay, so far so good. Any question? If there is no question, I will end this session.
One question, Doctor.
Yes.
Slide number 65.
This.
Yes.
How
do we know that the sign of the 22I node is positive?
Okay, because when the current flows to resistor, okay, the voltage drop must be positive first, okay, and then negative. Okay, so that's why positive 22.
So whenever in the circuit, for resistor, they are not stated the sign.
Yes.
So we can assume the current flow from positive to negative. Is it?
Yes. Okay. When a current flows through a resistor, okay, or through a passive resistor is passive element. When the current flows through a passive element like resistor, okay, the voltage drop across this element must be positive first, okay, and then negative. Positive and negative is the sign of voltage, not the sign for resistor, because resistor has no polarity. There is no negative and positive for a resistor. This positive and negative is the polarity for the voltage drop across the resistor. Okay, so when there is no notation of voltage drop across that resistor, okay, so that we just assume that the voltage drop across that resistor is positive and then negative. Okay, so when current flows through the element, the voltage drop is positive then negative. Can understand?
So for the slide 63, can you go back? Okay, that one, each of the resistor element, they put sign, right?
Yes, so we follow this sign.
Follow the sign. If they don't put it, the sign, if there is no sign, so we assume the direction of the current entering the positive.
Yes, positive. Yes, positive terminal of the voltage. Okay, because in this circuit, we don't know whether this rectangle, whether this rectangle shape is voltage source or resistor or what, we don't know. Okay, so just follow the sign of this.
Or it can be a voltage source or resistor, or any other elements. I thought that the rectangular shape is always a resistor.
Sometimes it's resistor, but for example, this circuit, we don't know which one is resistor, which one is voltage source, right? So in a circuit, there must be a voltage source, right? Maybe this is voltage source, this is voltage source, maybe this one voltage source, but this so we don't know. Just follow the sign.
I see, understand.
Chan, for M ni yang mana, Chan? Oh, yang tadi. This one, okay. So any other question before we end our session? Okay, if you have any question regarding this slide, just ask now. Okay, because next week we will discuss other subtopic.
Doctor, for this slide, if we consider the equation like voltage source supply equals to voltage drop,
okay,
boleh ke?
Can. So
Kena consider dia punya sign juga.
Kena, yes, must consider. So in this slide, we have negative, positive, 44, 55, and then before that we have what we call this dependent source, right? We can rearrange the circle like this. So this is 22 ohm. Okay, so negative here. So this is negative, positive. This is 5 I0. Okay. So the voltage supply, if you want to put voltage supply is equal to voltage absorbed. Okay. Voltage supply is these two voltage, right? Okay, so is this voltage? Positive here, negative. This is voltage of V of 22, right? Okay, so V of this is absorbed. Okay, V absorbed is equal to minus 5 I0 plus 55. Okay. So how to solve this? We have to find the I0, right? How to find the I0? What? Okay, so VA here is what?
22 I0 kan? Yang V
22 I0. Yes.
VA kan?
Yes, like this. So like this. So we can find 22 I naught plus 5, right? Same or not?
Oh, dia bukan negative 54 volt plus 5 I naught equals to 22 I naught. Bukan eh?
Wait. Negative, positive, negative, and negative. So 5 I naught. Current flow. Yes, like this. So 55 is equal to 22 I naught plus 2M. So 27 I naught is equal to 54, right? So I naught will be 2M, right? Isn't it?
Tak, cuba doktor
Yes,
consider
correct,
the
But why-
the first sign untuk setiap elemen tu. Let's say 54 volt tu first sign dia negatif kan. So kita ambil negatif 54 tambah dengan kalau ikut gambar doktor ni 5 positif 5 I naught minus 54
And then
equals to positif 22 I naught.
yes, 2M, right, Haziq? So this one is so this one is wrong. So I naught is equal to 2M. Okay. Oh, how come this book give the wrong answer? Okay, so this is VA. So tadi, can you repeat? Who's put just now? Positive 5 I naught, right?
Positif 5 I naught
Okay, minus 54, right?
minus 54.
Plus 22 I naught equal to 0. Right?
Oh, dia kena macam tu kan. Kena plus 22 I naught equals to 0. Dia tak boleh equals to 22 I naught terus eh. Pasal 2 tu kan voltage supply.
If you okay, 5 I naught minus 54, you want to put equal to, so this will be minus.
Kenapa dia minus? Pasal dia
Because
first sign dia positif.
yes, this is positive. Positive 22 I naught equals 0. And then this is normal solution of equation, right? 5 I naught minus 54 equal to minus 22 I naught. Okay.
Okay, maknanya alright faham. Nak kena consider equal to 0 juga ah.
Yeah, of course. If you want to put equal to, yes, if you want to like this, V supply is equal to V absorb, right? This is V supply. This is V absorb. Okay. But this equation is equal to what? This equation is equal to Vs plus Va equal to 0. The summation of, okay, the summation of. No, cannot write like this. The summation of voltages in a closed loop path is equal to 0. Sudah. Jadi berapa? Okay. The summation of, okay, KVL state that the summation of voltages in a closed loop path is equal to 0. So this is the summation of voltages. Okay. Okay. maybe you can understand tadi, student? Siapa tadi? Okay, let's consider this basic circuit. Okay, let's say we have 2 volt here. Okay, and then we have a resistor of 3 ohm. So current flows like this. Of course, this is the positive and negative of the voltage drop. Okay, so let's write the equation. Minus 2 plus 3 plus V let's say V1 is equal to 0. So V1 is equal to 2 volts, right? Okay, this is V1. V1 is equal to 2 volt. Okay, from this is the KVL equation, and we know that V1, this is V1. This is V1 is equal to 2 volt. Why? Because there is only one resistor here. Okay, so all supplied by the voltage source will absorb by this resistor. So this 3 ohm will get all 2 volts. Okay, and we know that the terminal, okay, is same, minus and positive, minus and positive. Imagine that you take a multimeter, okay, and then you put the positive probe here, the negative probe here, and you will get 2 volts. Okay, can understand? If yes, type yes.
Yes, Doctor.
Okay, any other question want to ask? Tadi Afiq tanya
Yes, yes.
Afiq dah faham?
Tu lah nak rujuk balik notes. Yep.
Okay, so okay, now let's say okay, let's say we have positive, negative. This is not a typical arrangement of voltage source. We have 3 volt here, and then we have a resistor of 2 ohm here. Okay, current. Let's say current flows like this. Okay, let's say current flows like this. So the voltage drop is positive and negative here. This is V1. So V1 is equal to, actually if you do not write KVL equation, equal to, this is 3 volt, this is 3 volt. V1 is equal to, please write your answer here.
3 volt.
3 volt. How about others? 3. How about others?
Same, madam.
V1 is minus 3 volts. Because negative, positive, positive, negative. Okay. If we take the multimeter here, one probe here, positive probe here, negative probe here. Okay. So the voltage read by 2 ohm is minus 3 volt because the voltage source is connected opposite with 2 ohm. Okay. If the terminal here is positive, same as this, so V1 will be 3. Okay. Now let's write KVL equation. 3, okay, positive 3 plus, right? Plus V1 is equal to 0. V1 is equal to minus 3 volts. Okay. So it is better to write KVL equation. Okay. if you confuse. So KVL equation is summation of voltages in a closed loop path is equal to 0. Afi, okay?
Okay, Doktor.
So in this circuit, we have two voltage source, okay? The arrangement of the voltage source is in opposite, right? Positive, negative, and then negative, positive. So maybe you will get confused, then better to write KVL equation. Now, we have to, okay, now we have, let's say we have two voltage source, 2 volts, and here is 3 volts, 3 volt, and then we have VA. Okay, now VA is equal to current flows like this. VA is equal to without writing KVL equation. Can you guess what's VA? Just 5. Okay, why? Because when current flows like this, the voltage drop across VA must be positive first and then negative. Okay, and we see that this positive is same like this positive, right? The arrangement, this negative, same. So same for this. This is the typical arrangement, negative, positive, and then negative, positive. Okay, typical arrangement of voltage source, and that is equal to this arrangement, positive and negative here. So just VA is equal to 2 plus 3 equal to 5 volt. If you want to write KVL, yes, can. So let's say minus 3, minus 2, and then plus VA must equal to 0. VA is equal to 5 volts. Okay. So, okay. Let's try the example. We have, okay.
Kalau kita nak tulis equation tu in terms of sum of voltage drop equals to sum of voltage supply, boleh juga? Sama tak kita dapat dengan tu?
Yes, we can. So voltage supply is 5, right? 2 plus 3, right? This is voltage supply. It is equal to voltage absorbed. It is equal to VA. Okay.
Oh, kalau kita tulis macam tu, kita tak consider yang sign yang first atau second tu lah. Maknanya kita just ambil value dia je.
Provided that the arrangement of voltage source is same for the both voltage source. Okay. So to be safe, write KVL equation. But this is very simple, right? The arrangement of two voltage source is same, right? Minus, positive, and then minus, positive. So the total of the voltage source here, okay, we know that it is 5. Okay. This one, the arrangement of voltage source is opposite, right? 54 with 5 I know is opposite, right? This one is positive, negative. This one is negative, positive, right? So you might do mistake. So it is better to write KVL equation to be safe. Okay, now let's try this. We have, let's say, here is 2 volts, and then negative, positive. Also, we have 3 volt here. How about the voltage drop here? Current flows like this. Okay.
Negative 5.
Yeah, good. Why? Because when current flows here, the voltage drop will be positive and then negative, right? Okay, but the arrangement of the voltage source, we know that the voltage source here is minus 5, right? 3 and 2. The arrangement is in the opposite way. So this is minus 5. The arrangement of voltage source is opposite with the arrangement of V naught, right? V out. So negative, positive, but here positive, negative. So we know that V naught is equal to minus 5 volts. Okay? If you apply KVL, you will get the same. Yes?
Both voltage source tu dia opposite orientation,
Yes.
so akan dapat either 1 volt ataupun negative 1 lah. Macam tu.
Sorry?
Cuba doktor buat voltage source tu opposite direction. Opposite sign.
Which one? On.
Salah satu.
Either one.
Either one.
Okay. Either one Okay, so negative, positive, here is 2 volts and then positive, negative.
Yes, correct.
3 volts. And then VA. How? VA, let's try without writing KVL. What do you think? VA is equal to?
Negative 1?
Minus 1.
Minus 1.
Minus
Betul
1. Minus 1. How about others? Without writing KVL. Okay, now let's prove. Let's write KVL. Minus 1. Okay. Why we just get, okay, now let's prove. Minus 2 plus 3 plus VA equal to 0. VA is equal to minus 1 volt. Don't forget to put the unit at your final answer. Okay. So this is with KVL. Okay. This is without KVL. Just think. Right. Just congak. Just count in your brain. So VA is the terminal, the sign of VA is positive, negative here. Okay. So is so the voltage source here is opposite. Okay, 3 volt and 2 volt is opposite. So 3 and 2 the difference is 1, right? Okay, but we take the, so this is 2 minus 3, or we take the larger one. The larger voltage source is 3. We follow the orientation. It is negative. Okay. You may try this. Okay, and then prove with your calculation of KVL, and then you think. Okay, think how to next time you want to just calculate in your brain, not writing the KVL.
Boleh buka slide nombor 8.
8. Okay. Yang ni ke?
Betul. Situ kan dia cakap voltage source can be connected in series but cannot in parallel.
Yes.
Sebab nanti dia akan lead to smoke kalau ikut dia punya gambar aja.
Yes.
Boleh explain tak benda tu macam mana dia boleh lead to smoke tu?
Okay, because voltage source cannot be connected in parallel. Because parallel connection must share, must have the same voltage. Okay, parallel connection must be same voltage. Okay.
Kalau ikut Ohm's law tu, itu yang kita faham lah. Maknanya series circuit, the current is same semua kan. I total equals to I1 equals to ni. So untuk parallel circuit, dia punya V dia sama kan untuk semua.
Yes.
Cuma yang bila dia kata smoke tu, contoh, andai kata dia ada dua voltage source in parallel, macam mana dia boleh jadi smoke kan tu?
Because of this, okay. So let's say we apply KVL in this circuit, right? So minus 3 plus 2 Okay. Minus 3 plus 2 will be equal to 0, right? But then 2 equal to minus 3, right? 2 equal to minus 3. Is it 2 equal to minus 3? No. So 2 equal to 3. But 2 is not equal to 3. Right? 2 not
betul.
equal to 3. Okay. So this is the explanation. Okay. The current flowing between the batteries during this process, okay, during the parallel arrangement will be quite high. It is equal to the difference between the two voltage divided by the sum of the internal resistance of the battery. So in battery, we have internal resistance. Okay. So how to calculate the current flows through this circuit? I equal to V over R, right? So this portion is V, this portion is R. Okay. So V is equal to what? V here is equal to 3 minus 2, right? Divided with, let's say the internal resistance in a battery is 150 milliohms. Okay, so 150 plus 150, so we get 3M. 3M is considered as high. Okay, but parallel arrangement of battery exists. Okay, just imagine that your car is the battery is weak, and then you take battery of other car, right? And then you jump the battery, right? So the connection is in parallel, but the voltage of both car must be the same, 12 and 12. Then it can be connected in parallel. Okay, there's an example of parallel arrangement of voltage source.
Kita tengok yang explanation yang tengah-tengah tu, dia kata if the second battery, the lower voltage is rechargeable. So the first battery tu akan charge yang lower voltage second battery tu kan?
The battery with the highest voltage will discharge into the other one until they end up with equal. If the second, it will be charged with the first one until the two have the same. Okay, intermediate. And then both intermediate, 2.5, 2.5. Kalau lah rechargeable kan?
If rechargeable, so there is no smoke lah. Dia hanya charge the second battery je lah.
Yes, because it have the same voltage. Same value. Same value is okay. Okay. It is like the like I said just now, we want to jump two batteries of cars. So the value of the batteries of two cars are the same, 12 and 12 volts.
Betul, faham. Terima kasih.
Okay. Same goes for current source. Current source can be connected in parallel, but cannot be connected in series. If the current source is different, if the current source is the same, can be connected in series. Okay. Any other question? No. If no, we can end our session. Okay, but before that, I will take your attendance. Okay.